All right, everybody, here is your video key for PA.8, piecewise functions. So here we're going to graph two different lines, y equals 2x plus 1 and y equals 3x minus 4. But we're only going to graph the green line where x is less than -1 and the blue line where x is greater than or equal to -1. So first, I'm just going to graph the whole line. So 2x plus 1, start with the y-intercept and use your slope of 2. So we have a y-intercept of 1 and a slope of 2. So up 2 over 1, up 2 over 1, or you can go down 2 and left 1, down 2 and left 1. And I'm just going to draw that entire line. Okay, and it's going on forever in both directions, but we're going to adjust that later. And then let's graph the blue line, 3x minus 4, so a y-intercept of -4 with a slope of 3. So you start down at -4, 1, 2, 3, 4, which is right here. And it has a slope of 3, so up 3 over 1, up 3, 1, 2, 3 over 1. We can go down 3, 2, 3, and left 1. And so we have a line that looks something like this. So now what's weird about piecewise functions is we're not going to graph the whole line like we just did, actually. We're going to only graph a certain part of the line based on what the problem tells us to do. And so here, for the green line, we're only going to use the green line when x is less than -1. If you look down here, this is how it's written in function notation, as we've probably talked about in class already. So 2x plus 1 is going to be graphed, which is the green line, but only if or when x is less than -1. So we're going to look at this. And so when x is less than -1 on the graph, that starts at this point and it goes that way. So we got to get rid of all this green line that's up here. So starting right here, that's the only thing we're allowed to use, and we got to get rid of everything else. Oops. So there we go. So that is the green line only graphed when x is less than -1, which is this. Now we got to take our blue line and only graph it when x is greater than or equal to -1. And we'll come back in a second to the difference between these two symbols. But x is greater than -1, we'll start here, and we got to go this way on the blue line because this point is when x is 0, this is when x is 1, this is when x is 2, and we're using values when x is greater than -1. So now we have to erase this part of that line. All right, now the difference, right now we don't have a function because this point is right above that point. It would fail vertical line test. But in the green line, it says x is strictly less than -1. It's not allowed to equal -1 like the blue one is. And so this green point right here isn't actually a point at all. It's a hole. So something like that. And now the hole means that that point does not actually exist. You just get really, really close to that point forever, like infinitely close. But you will never reach an x value of -1 on the green line. It's not until you jump down to the blue line that you get an x value of -1. And so that is how you graph a piecewise function. So let's do another one here. Our blue line is -x minus 1. So we start here. -x is a slope of -1, so down 1 over 1 like this. Just always make sure if the problem has a negative slope that you're going downhill. If it's a positive slope, you're going uphill. Okay, so we have this. Now I'm not going to, well, I guess I'll draw the whole line on this one. I changed my mind. All right, so here's the whole line, but we're only using the blue line if x is less than 3. And so starting at 3, 1, 2, 3, starting at this point right here, we got to erase all this. So 1, 2, 3, we got to erase this stuff that's over here. Oh, what was that? Because that's not part of it. And so the blue line is only graphed if x is less than 3. The green line, 2/3 x minus 4. So we start at -4. 1, 2, 3, 4 right here. And 2/3 means up 2 over 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. All right, that didn't look right. But then we're only graphing the green one when x values are greater than or equal to 3. So we're going to use this point and go this way. We're not allowed to use any of these points because this is where x is equal to 3 right here. So now I'm not even going to draw the whole line and erase it. I'm just going to draw where I know the line is supposed to exist, which is right there. Erase this other point because that's an x value that is not greater than or equal to 3. And then we got to check for a hole in the graph. And our blue piece should have a hole right here because x is only allowed to be less than 3. So we can just adjust that and make that a hole right there. And so there you go. Okay, this problem here is very similar, except that this middle piece right here is a little bit weird. So we'll talk about that in a second. But we're going to graph the pink piece plus 1 or as our y-intercept and a slope of negative 1/2. So 1 up 1 over 2 in this direction. And I'm going that way because I'm only graphing it if x is less than 0. And so I don't want to use a point where x is equal to 1, 2, or 3. Jump down to the orange piece, and we're only graphing that when x is greater than 0. And so this is a line whose slope is 1, and the y-intercept is 0. But now we have a hole there because x has to be greater than. We also have a hole in the pink line because x is only less than, it's not less than or equal to. So that's got to be a hole also. So they're both holes now, which is weird. We have a slope of 1, so up 1 over 1, up 1 over 1. So that piece looks like that. Now this third piece in blue here, this is just saying this is our y value when x is 0. So it's just a point, 0, 4. Just a single point, 0, 4, 1, 2, 3, 4, right there. And that's it. So that's what that graph looks like. All right, jumping down here. Now this one's going to be slightly different also. But again, the purple and orange are going to be the same that we've been talking about. So let's start with the purple. Has a y-intercept of negative 1 and a slope of negative 3/2. So up 3, 1, 2, 3 over 2. Up 3, 1, 2, 3 over 2, 1, 2. But we're only using the purple line if x is less than negative 2, which means this point is no good. So I'm going to get rid of that point. Go back to my hole eraser. Get rid of that point. It's only less than negative 2, so actually I'm going to get rid of that point and make it a hole. 1, 2, 3, 1, 2, that was right here, right? And then from there, the graph looks like that. The orange piece, actually we'll do the green piece next. The green piece is x plus 1. So starting here at a y-intercept of 1 with a slope of 1. But we're only allowed to graph it out to x equaling 1 and x is negative 2. So down 1 over 1 and down 1 over 1. We have to stop this one right here. And that's it. We're only graphing this line between x is negative 2 and x is 1. And that's what this is telling us. Notice how they're both are equal to, so all these points are filled in. And so this is like a line segment. It's just that piece of the line right there. Like that. And then we graph this one. Now this one's kind of weird. This is just the y value always. So this is a horizontal line when x is greater than 1. So at 3, 1, 2, 3, x greater than 1, so not or equal to. And it's just a horizontal line going this way because it's just always equal to 3. So that one had a couple weird things going on there, but that's how you do that. And then now let's go backwards and let's write the function that is represented here. Sorry, I actually want to get rid of that point and pretend that one's not there for what we're doing for now. Maybe we'll come back to a problem like that later. So just the blue piece. So find your y-intercept, which is right here, which is 2, and then count your slope down 2 over 1. So it's a slope of negative 2. So it's negative 2x plus 2. But then we have to say right here what x values we use this for. So notice how it starts at an x value of 1, and then it's going that way. So x has to be less than 1 for the blue piece. And it's not or equal to because we have a hole here. We also have a hole in the pink piece, so we're going to be not or equal to on that one either. Now for the pink one, find your slope, up 1 over 1. So the slope is 1. So it's just going to be x. And then even though this line stops here, we could imagine that the line just goes on forever. Use the slope and find the y-intercept, and then that's still going to be what's in our equation. So from this point with a slope of 1, you go down 1 over 1, and our y-intercept, therefore, is at negative 3. So it's x minus 3, and this is used for x values greater than 1. And so that's how you can take a graph and write the piecewise function. On number 5 here, I changed these questions, so I wrote them in. But now we want to know the same questions we've been asking in the other part of this unit. This is giving us an x value, so we're looking at the graph and just finding a y value. So g of 0, when x is 0, our y value is 4. So g of 0 equals 4. G of negative 1, same question. When x is negative 1, now here, this is where x is negative 1. But remember, this part is a hole. That means that point does not actually exist. We only draw it so we can talk about it, because the graph does get super, super close to that point, but it's never going to reach it. So the y value will always be where the dot is filled in, which in this case is 0. So g of negative 1 is equal to 0. And then finally, the purple one, this is when it gives us the y value. So find when the y is equal to 4, and that's right here, but also right here, y is equal to 4. So we have two answers on this one. So g of x equals 4 when x equals 0 and negative 9, which is the one right here, negative 9. Okay, so reading a graph and answering questions. And then here's another, given the graph, let's write the piecewise rule for the function. And so we have f of x equals, we're going to have 3 pieces. So make a big squiggly. The green piece, its slope is from this point up, like to this point, is up 1, 2, 3 over 1. So its slope is negative 3. And then follow that slope, 1, 2, 3 over 1, and its y-intercept, therefore, is negative 1. And it's only used for x values that are less than negative 1 or equal to, because that point's filled in. So now we say x is less than or equal to negative 1. The blue piece has a slope of 1 and a y-intercept of 2. So its equation is x minus 2. But it is only graphed between two x values, negative 1 to 2. And so that's where you say negative 1 is less than x is less than 2. Anytime like a piece of your graph has a starting point and a stopping point, that's when you're going to write x in between two numbers like that. And then the pink one has a slope of, it looks like 1, 2, up 2 over 1. So go down 2 over 1, down 2 over 1, and our y-intercept is negative 7 for the pink piece. And our slope was 2, so 2x minus 7. And this is used starting at an x value of 2. So this is x is greater than or equal to 2. And that's how you do piecewise functions.